Hey everyone, and welcome to another deep dive with us. Today we're going to be unpacking something pretty massive. We're talking about the Big Bang, but we're not just talking about the event itself.
Right.
We're going to trace its impact all the way to you. You heard that right.
Yeah.
You are a product of the universe's biggest bang.
It's wild to think about.
It really is. It's like, whoa, we're
Yeah.
literally made of the universe. But before we get to us,
Yeah.
we got to rewind way back. I'm talking before there was even a beginning. What was there before the Big Bang?
It's hard to even picture, but
Yeah.
imagine no space, no time, not even emptiness as we understand it. Just pure potential packed into an infinitely small point.
Okay, infinitely small. That's a concept that kind of makes my brain hurt.
It's mind-boggling for sure. Think of it this way. All the matter and energy that make up the entire universe, everything we see and can't see, squeezed into a point so small it has no dimensions. The density is just beyond comprehension.
So it's not just tiny, it's like unimaginably dense.
Exactly. And from that point of unimaginable density came the Big Bang, a sudden rapid expansion of space and time itself.
So it's not like an explosion in space, it's the explosion of space.
That's a great way to put it. The Big Bang didn't happen in something. It created everything.
Whoa. Okay, that's a game changer. So no Big Bang, no universe, no us.
Right.
It really is the ultimate origin story. What I don't get is, if everything was packed so tightly together, how did it suddenly just explode outward?
That's one of the biggest mysteries in cosmology. We know it happened, we see the evidence, but the exact mechanism that triggered the Big Bang is still being debated today.
So science still doesn't have all the answers. I guess that makes it even more exciting.
Absolutely. There's so much left to discover. But here's what we do know. In the first fractions of a second after the Big Bang, the universe was incredibly hot and dense.
Hot and dense, so kind of like soup.
Well, a very energetic soup. More like a plasma, actually, where atoms as we know them couldn't even exist yet. Imagine a sea of pure energy, constantly transforming as the universe expanded and cooled.
And I'm guessing this cooling process was pretty crucial.
It was the key to everything. As the universe cooled, energy began to condense into particles. Think of it like steam turning back into water droplets.
Okay, so we're going from a super hot, chaotic mess to something a little more organized.
Exactly. Those particles eventually formed the first simple atoms, mostly hydrogen and helium. These are the building blocks of everything else.
Right, I remember learning about those from the periodic table. But hold on, we're still talking about just hydrogen and helium.
Yeah.
How do we get from those two elements to all the amazing complexity we see in the universe today? Like, planets, people, and chocolate.
That's where things get really fascinating. Those simple atoms didn't just float around. Gravity started pulling them together, forming distant clouds of gas. And these clouds eventually collapsed under their own weight, igniting the first stars.
Stars, now we're talking. I've always been fascinated by stars. So how did they help create everything else?
Stars are like cosmic alchemists. Deep within their cores, under immense pressure and heat, hydrogen atoms fuse together to form heavier elements. It's a process called nuclear fusion.
Nuclear fusion? That sounds intense.
It is. It's the same process that powers the sun. And within those stellar furnaces, elements like carbon, oxygen, nitrogen, and even iron are forged.
Wait, so the atoms that make up our bodies, our planet,
Yeah.
they were literally created inside stars.
Yeah.
That's incredible.
It's truly remarkable. And here's the thing. Stars have life cycles, just like us. Some stars, after they've created all these heavier elements, explode in spectacular events called supernovae.
Supernovae. They sound pretty dramatic.
They're the most powerful explosions in the universe.
Yeah.
And they're crucial to our story because they scatter those star-forged elements far and wide across space.
So like a cosmic seed spreader.
A perfect analogy. These scattered elements become the raw materials for new stars, new planets, and ultimately for life itself.
Okay, my mind is officially blown. We went from a point of infinite density to atoms, to stars, to explosions that spread the building blocks of life. It's like a giant cosmic chain reaction.
It is. And you know what's really mind-blowing? We can still see evidence of the Big Bang today, billions of years later.
Evidence of the Big Bang. You mean like fossils, but for the universe.
Not exactly fossils,
No.
but something just as amazing.
Right?
It's called the cosmic microwave background radiation, or CMB for short.
CMB, that sounds familiar. Is that something to do with static on old TVs?
You got it. Remember how we talked about the early universe being incredibly hot and dense?
Yeah.
Well, as the universe expanded and cooled, that intense heat and energy didn't just disappear. They transformed into a faint afterglow that permeates all of space. And a small fraction of that afterglow shows up as static on our TV screens.
Wait, so that fuzzy, snowy static, that's literally leftover heat from the Big Bang.
It's a bit more complicated than that, but essentially, yes. Think of it this way. The Big Bang was like a giant flashbulb going off, and the CMB is like the fading light from that flash stretched out over billions of years and across the entire universe.
I don't even have words. It's like looking back in time to the very beginning.
It is. It's one of the most important discoveries in cosmology. And by studying the CMB, scientists have been able to learn a lot about the early universe, like its age, its composition, and even its shape.
So it's not just a cool visual. It's like a gold mine of information about the Big Bang.
Exactly. And here's where it gets even more fascinating. Remember how we talked about stars creating heavier elements and spreading them through supernova explosions?
Yeah, the cosmic seed spreaders?
Well, those scattered elements didn't just disappear over billions of years. They clumped together under the force of gravity, forming new stars, planets, and eventually life.
Okay, I think I'm starting to see where this is going. You're about to tell me that we're all made of stardust, right?
You're catching on. Every atom in your body, from the calcium in your bones to the iron in your blood, was once part of a star that lived and died billions of years ago.
So we're not just connected to the Big Bang. We're literally made of this stuff of stars. It's so poetic.
It is. It's a reminder that we're not separate from the universe. We're a part of it. We are the universe experiencing itself.
Wow. That's a deep thought. So if we're all walking, talking pieces of stardust, does that mean we're all kind of special?
I'd say so. But here's something else to consider. You know how we talked about the Big Bang being this incredibly powerful, sudden expansion?
Yeah.
Well, it turns out that the force of that expansion had to be incredibly precise for the universe to exist as it does today.
Precise. You mean like if it was a little bit stronger or weaker, things would be totally different.
Exactly. If the Big Bang had been just a tiny bit stronger, the universe would have expanded too rapidly for gravity to pull matter together to form stars and galaxies. Everything would have just kept flying apart. A vast, empty void.
Okay, that doesn't sound very fun. And what if it had been weaker?
Then the universe would have quickly collapsed back in on itself, like a deflating balloon. No stars, no planets, no us.
So we're basically riding this razor's edge of cosmic existence. It had to be just right for us to even be here.
It's a remarkable concept, isn't it? Scientists call this the fine-tuning problem. It makes you wonder if there's something deeper at play, some underlying principle that made the universe just right for life to emerge.
Like some cosmic architect designed it specifically for us.
Well, that's one possible interpretation. Some people see it as evidence for a creator or a higher power. Others believe there's a scientific explanation we haven't discovered yet. Maybe there are countless other universes out there, each with different properties. And we just happen to live in the one that's conducive to life.
Whoa, multiple universes. That's a whole other deep dive we could explore.
Right.
But even if we don't have all the answers, the fact that we're here talking about this, experiencing this incredible universe, it's pretty mind-blowing.
Absolutely. It's a reminder to appreciate the sheer improbability of our existence and to make the most of this precious gift we've been given, this universe with its vastness and its mysteries. It's all connected to that one momentous event, the Big Bang.
And to think.
Yeah.
It's still unfolding, still evolving, still full of surprises.
It is. And that brings us back to you. Remember that question our source material posed? What will your Big Bang be?
Oh, yeah. I was wondering about that. It sounds pretty profound.
It is. It's a reminder that we all have the potential to create, to innovate, to make our own impact on the universe. Just like the Big Bang sparked the creation of everything we know, we too carry within us the power to spark change, to make a difference, to leave our mark on the world.
I love that idea. Our own personal Big Bangs. It makes me think about all the incredible things humans have accomplished. I mean, we went from living in caves to building rockets that can travel to other planets.
It's quite a journey, isn't it? And who knows what the future holds?
Right.
With advances in technology and our understanding of the universe, the possibilities seem endless.
Exactly. We could discover new life forms.
Yeah.
Unlock the secrets of dark matter and dark energy. Maybe even figure out how to travel faster than light.
Or maybe we'll find that the answers to the universe's biggest mysteries lie within ourselves.
Oh.
Remember, we are part of this grand cosmic story, not just observers. We have the potential to shape the future.
Right.
To make our own contributions to the ever-evolving tapestry of the universe.
That's a powerful thought. So what's the one thing you want our listener to take away from this deep dive?
I'd say it's this. Never underestimate the power of curiosity.
Hmm.
The same curiosity that led us to discover the Big Bang, to explore the stars, to unravel the secrets of the universe. That same curiosity resides within each of us.
Yeah.
It's what drives us to learn, to grow, to
Okay.
explore, to create.
I couldn't agree more. This whole deep dive has been a journey of discovery, and it's made me realize that there's so much more to learn, so much more to explore, both within myself and in the universe around me.
And that's the beauty of it all, isn't it? The universe is vast and mysterious, and our journey of understanding is just beginning.
So to our listener out there, keep looking up, keep asking questions, and keep exploring. Who knows what incredible discoveries you might make.
And remember, you carry the spark of the Big Bang within you. Let that spark ignite your passions, your dreams, and your own personal journey of cosmic exploration.
Beautifully said. That's a wrap on this deep dive into the Big Bang. Until next time, keep exploring.